So this is number 15 on that first problem pack. A person driving her car at 50 kilometers an hour approaches an intersection just as the traffic light turns yellow. She knows that the yellow light lasts only 2 seconds before turning to red, and she is 30 meters away from the near side of the intersection. And apparently she's able to slow down time to figure this all out in the time that it takes to make a decision. Should she try to stop or should she make a run for it? The intersection is 12 meters wide and her car's maximum deceleration is -6. Also, her car takes 7 seconds to accelerate from 50 to 70. Ignore the length of her car and her reaction time. So, I'll draw the car. Artist's rendition may be worse than it actually appears in real life. There's the intersection, right? So she's 30 meters away and this is 12 meters. And she only has how much time? She has 2 seconds. So the question is, can she get from there to there in 2 seconds, which is of course the distance of 42 meters, or can she stop in that amount of time? Can she stop in less than 30 meters? So there's really 2 questions, and then the answer is, well, which one is better? Maybe both are possible. Who knows? Does that get you started, Austin? Tanner, does that get you started? Should I continue a bit more? Okay, well, let's figure out which one you want to do first. Does it matter? Let's do the deceleration one, right? So her acceleration, her slowing down is -6, and she has to do that in 30 meters. What is her initial velocity? You're doing 50 kilometers an hour, right? So let's go 50 divided by 3.6 first of all. $13.9. So I think all you got to do is go VF squared equals VI squared plus 2AD. What's the final velocity? 0. What's the initial velocity? 13.9 squared plus 2 times that acceleration of -6. And her D is, what do I do? Because I don't have to solve for anything. Pauline?
Can try first to try to know in how many times she can stop.
How much time?
How much time?
Okay. You could. It's kind of a weirdly worded question, because what they're really saying is you have 30 meters to stop, but the question is, can she do it? So you're really solving for the displacement and then comparing that value to the 30. Does that make sense? Okay. So I'm going to take that 13.9 squared to the other side, 13.9 squared, and I'm going to divide by -12, right? 2 times -6. And I'm going to get a displacement value. And that's going to be 13.9 squared divided by 12. And I get a displacement of 16.1 meters. In other words, she can easily stop. No problem. Easily. In fact, she will have lots of room to spare. Right? So yes, she could stop. So take that thinking now to the other part. I'm going to give you a minute or so to try that. Try that other part. Should I get you started a little bit? The question is, can she travel the 42 meters in 2 seconds? So it's the same idea. You're going to solve for the displacement and see how it compares to 42 meters. I'll give you a minute and then I'll try it, and then I'll show you. Okay, I have your answer up here. So first thing is to convert your 50 and your 70 into meters per second, which I hope you can all do, 13.9 I did before. Then you got to find the acceleration that her car actually has. So I use VF equals VI plus AT. I put 19.4 in, I put 30.9 in. I put 7 seconds in because that's what it says in the question. That's how long it takes her car to go from 50 to 70. 7 seconds from 50. 1, 2, 3, 4, 5, 6, 7. My bicycle can go faster than that. my grandma riding it. Her acceleration is 0.79. And then you're going to put that in d equals vit plus a half at squared. But make sure you use the 2 seconds, because that's how long she has to get through the intersection. 13.9 times 2 plus 1/2, 0.79 times 2 squared. And in fact, you find out that not only will she not make it, she doesn't even 29.38. She doesn't even get to the start of the intersection. She's like entering the intersection on the red light. That is a definite ticket happening. And then back up. Okay? So clearly, the moral of the story is hit the brakes. That's the moral of the story. Not a particularly hard question, but the challenging part is knowing what to do, because you don't know what to do when you have this displacement, right? So you may get a question like that. You may see something where it says, will you be able to do this? And then that's your idea, is you have to solve for that value and compare it to what you've been told.